Basic properties of fluid and solid. Okay, so there are some key difference between fluid and solid. So I think the questions in test may ask when it's theoretical you have to talk about these things, and then also difference between fluid and solid. Later I'll just do a summary on what are the things that the test may come up. Okay, for this topic, and just to let you know fluid and solid, the difference are three things. Okay, attractive force, deformation, and the shear stress itself, they behave differently. So for attractive force wise, hold on a while. So the attractive force for the solid itself, they hold on together so strongly. Okay, this is solid. So if you were to try to push it, okay, so you retain its shape. Okay, try to retain its shape. But for fluid wise, their bond is weaker than solid. So therefore, when you give it a push, the fluid will start to flow and continue to flow until happy. Okay, for deformation wise is also different. So what's the difference is that give me a moment. Okay, so similar to a little similar to attractive force, but now is in terms of a more macro one. So imagine you have a solid over here trying to push it, and you're trying to push, right, you're trying to deform it, right. It eventually you will start to you pull it in this manner, and after that when you release you will start to go back a little and then stop there. You will not deform that much. But for liquid wise, when you start to pull it or push it, it start to flow. I don't know what the hell. So you'll not go back to its original shape, or go back to its near to its original shape. Like let's say this solid, let's say you have a shear stress on it, you'll just go into this direction, and then maybe will go back to its usual shape, but maybe a little sheared, maybe in this shape, but you'll retain that shape. For fluid, instead it start to flow all the way. And then for shear stress wise, I don't want to derive the shear strain, shear and strain, formula, but just to show you the relationship is that shear stress is equal to tau, okay, as you know, but rather than they are affected by the area, which is not shown here, and then d is the deformation distance, which is due with a little thing about the strain itself. So I'm not going to talk about it. So therefore, it's related. Okay, so we can say that just to take note that for the solid itself, the shear stress is equals to the deformation itself. Is proportional to the deformation itself. It's proportional. Okay, it's proportional. Sorry, proportional, because it talks about the strain. So it's not equal. It's proportional. So, well, rather than fluid itself is proportional to the rate of the deformation, as you can see in my very long video. This is the function of u and y, right? So the u is the speed of the plate, okay, the velocity of the plate, and then this is the velocity of fluid. So the velocity of the viscous fluid is dependent on the plate itself and the height itself. So if the height is at 0, the velocity is actually 0. So this is what it means, and therefore it is dependent on the rate of the velocity. Okay, rate, how it changes. So you have to know. So the difference is just for solid proportional to the formation, and for fluid proportional to the rate of deformation, the rate of it. Okay, so and then for liquid and gas, the difference you also have to know. Okay, has a definite volume. There's no definite volume, you cannot contain it. And then density variation is little with temperature. And then for gas itself, varies considerably, and then less compressive. Is easier compressive than liquid itself. So then solid is very tough to compress. So you have to know these very fundamental things. Okay, and then you have to compare with the last year test, see whether will this come out or not. So maybe I'll just continue first. So I'll just talk about what are the things that will come out in the test for this topic, I guess. So maybe this one I think they'll come out. They'll talk about the surface force, and then the the formulas, especially the one for for this, if you remember, where's my, yeah, for this one, tau is equals to this. Later in the tutorial then you'll know what I mean. So partly the test for calculations will all deals with the stress, the shear stress and the shear force. Okay. And then conceptual wise, maybe they'll ask you about the classification of fluid flows. Maybe they'll talk about for calculation also talk about the Reynolds number. You have to calculate the number and then deduce whether laminar or turbulent. And then typically I think they will ask you for the key difference between fluid, solid and gases. Okay, so you have to be able to articulate between that. And then maybe assumptions. If you remember, what are the assumptions for shear stress? If you remember just now, as I written, no slip, no pressure gradient, assume they're proportional. The velocity, the rate of change of the velocity of the fluid itself is proportional to the height of the distance between two plates. Okay, and then the physical causes, I don't think they'll ask, but it's good for you to know. So I think I generally covered the topic 1, and it's pretty easy. So after that, now we talk about this is wow. So I'll just leave it to the next video. So I think that's it for topic 1. So I'll see you in topic 2.